Let's look at 16. So we want to find the Taylor series for each function centered at the given value of a. So these ones are important. It doesn't say do it by the definition, so we can use any techniques we want. So let's go ahead and look at these. So this first one is x, oops, wrong color, x minus 1 squared e to the x at a equals 1. Okay, so I want something, the goal is to get something that looks like n equals 0 to infinity with some coefficient Cn, x minus 1 to the n. That would be a power series centered at 1, or a Taylor series centered at 1. And things are looking okay. This x minus 1 squared is completely fine. But this e to the x isn't quite what I want. So what I'm going to do to fix it is say it's x minus 1 squared e to the x minus 1 is the ticket. That's what I want. But that's different from e to the x. How so? It's e to the x times e to the minus 1. Or I should write e to the x times e to the power 1. So the magic idea is e to the x is the same thing as e to the x minus 1 plus 1 is e to the x minus 1 e to the 1. And the whole reason I do that is to get this x minus 1 here. So this is equal to the x minus 1 squared, can't do anything. We'll wait on the e, and now this is sum n equals 0 to infinity. And this is just a formula you have to know, that when you expand e to the something, you get whatever's in the power to the n over n factorial. And now I bring in the boys out here. X minus 1 squared. This is x minus 1 to the n plus 2 times e, all divided by n factorial. So that gives us a power series expansion, or a Taylor series for that thing. So that's A. And then B, what do we have? We have x sine of 2x squared. So again, I'm going to use this idea. Sine of an empty box is the sum n equals 0 to infinity of minus 1 to the n, x to the 2n plus 1 over 2n plus 1. But not x, empty box. So then this is x times sum n equals 0 to infinity of minus 1 to the n. And now I put in 2x squared to the 2n plus 1 divided by 2n plus 1 factorial. I didn't write that here, but it is supposed to be factorial. So I get x sum n equals 0 to infinity, minus 1 to the n still, 2 to the 2n plus 1, x squared is going to be x to the 2 times 2n plus 1 is 4n plus 2 over 2n plus 1 factorial. So this is sum n equals 0 to infinity, minus 1 to the n, 2 to the 2n plus 1, x to the 4n plus 3 over 2n plus 1 factorial. Okay, and that's our final answer. So it sounds like it's a problem that would be really hard, but they're actually not that bad. It just comes down to knowing these formulas, and luckily you have a half sheet you can put those on.